right, welcome to Algebra 2, Chapter 2. Today we're going to cover Section 2.1, which talks about relations and functions. And we're going to answer the essential question, how can I tell if a relation is a function? So you should be able to answer that question by the end of the lesson today. All right, so a relation is a set of ordered pairs. Now, some of you might not remember what ordered pairs are just off the top of your head. So ordered pairs are like points. Like if I had 2, 0, -1, 1, 3, -4. Those are all ordered pairs. So the relation is the set of those ordered pairs. Now the domain is the first set of coordinates, which is like the x values. So in this case, we have 2, -1, and 3 would be in our domain. And the range are the second set of coordinates, which are the y values. So we would have 0, 1, -4 would make up part of our range. So let's take a look at our example. Okay, they gave us some data here and they want us to find the domain and range of the ordered pairs listed below. So we have age and height. Now, whenever they give you a chart like this, the first set of coordinates are your x values and the second set are your y values. Okay, so remember the domain was associated with the x values. So over here I'm going to write out our domain. And also, when you're writing these out, there's something important that you need to remember. The values need to be listed in order from least to greatest, and we don't ever repeat values when we're writing these out. So let's go back up here to this example and we'll do that. So for the domain, our lowest number would be 14, and then we have 18. Now 18 is repeated, but I don't need to write it twice. And then I have 20 and 21. So that would be your domain. Now sometimes you'll notice that in the book they're listed in brackets, so you might see it that way also. Now the range would be the y values listed in order from least to greatest and none of the numbers repeated. So we're going to start with 4.25 and then 4.4 and then 4.85 and then 5 and then 5.25. And again, you can put the brackets on if you wish. All right, so that's pretty much it for domain and range. So that's really easy. I have the answers written down here again if you'd like to double check. And feel free to pause the video and try to answer the questions ahead of time if you feel like you understand. If not, you can just follow along. Anytime you have questions, you can also write those in the left-hand column and I can help you answer those in class. All right, now we're going to talk about functions. So the definition of a function, I think of a function as like a machine. So we're putting something into the machine, it's doing something inside there in the equation, and then there's an output, something comes out. So if I were to plug in a 2, then it would go through the equation and then a number would pop out. Now if it's a function, for every value that we plug in, there should only be one value that comes out. So for each x value, there's only one y value. In other words, basically the x values cannot repeat. That's really, really important. So we have some charts below, and they want to know, are the relations below functions? So if we look, we have the points 2, 0, 4, 2, 6, 4, 8, 6. Okay, for every x, there's only one y. I don't have any x values that are repeated. So this one would be a function. So I'm going to write yes next to that. Okay, on the second one, I have 0, 8, -2, 3, -4, 0, and -2, 5. So in this one, you'll notice that the -2's repeat. So if I plug in -2 into my machine and it works in the equation, then I get two numbers that come out. That doesn't really make sense. So this one is not a function. And again, here are the explanations for those. Okay, now there is something that you can use to help you determine if a graph is a function. So let's say we don't have charts or ordered pairs, and we don't want to look at all the points on the graph. We just want to look at the graph and tell is it a function or not. We can use the vertical line test. So first, you're going to draw vertical lines across the graph. Okay, then you're going to check to see if the line crosses the graph at only one point for each line. So if your vertical line crosses the graph more than once, then it's not going to be a function. Okay, if it only hits at one point, then it is a function. All right, so let's take a look at some graphs, and you can tell me if they are functions or not. So this graph is this kind of purple line right here, or red line, and we're going to do the vertical line test. So we're going to draw vertical lines through the graph. Now we're going to check to see if our lines touch at more than one point or just one point. So here I got 1, 1, 1, 1, 1. So this one is a function because the line only touches the graph at one point. Now let's try this one. There's nothing over here, so it's really not necessary to draw the lines on the left side, but we'll do it anyway. If I look at this one, this line touches here and here, here and here, here and here. So this one is not a function because the vertical lines touch the graph at more than one point. Here's your explanations for those. Now, there's another way to represent ordered pairs called a mapping diagram, and it looks like this. It shows the input, which is like the x values, and the output, which is like the y values. So if we look at our question on the left side, it says, what is the set of ordered pairs represented by the mapping diagram at the right? So if we look at the arrows, it has -2, -3, -2, -2, -1, 1, 1, 3, 2, -2, and 3, 1. So that's your set of ordered pairs right there. So we'll uncover this so we can see. So there's your set of ordered pairs. Now, I bet you're probably going to know or guess what the question is that's coming up next. Okay, does the diagram represent a function? Why or why not? So let's take a look again. You can look at the diagram or you can just look at the points that we just wrote down. The first thing that I notice is that -2 repeats. So if I plug in -2, I get -3 or I get -2, which doesn't really make sense. So this one is not a function because some of the x values are repeated. All right, now we're going to talk about graphing equations. This is kind of just a refresher. They want us to graph the equation y equals -2x minus 1. Now, you guys might remember how to graph this using slope-intercept form, but let's say you just totally forgot, you don't know how to graph at all. You can always just plug in numbers for x every single time. So you can make a little chart, you can plug in any numbers you want for x, and then graph the points, always. So we're going to do just that. First, we're going to make a table of values. And I chose just some random numbers to plug in for x. But when I do this, I like to plug in negative numbers, 0, and positive numbers. That way I can see all the way across the graph and kind of get a feel of what my graph is going to look like. So let's say that I plug in -2 for x. So I get y equals -2 times -2 minus 1. So if I work that out, -2 times -2 is 4, minus 1 is 3. Okay, then I'm going to plug in -1. So same thing, -2 times -1 minus 1. So -2 times -1 is 2, minus 1 is 1. Okay, then I'm going to plug in 0. So -2 times 0 is 0, minus 1 is -1. You should kind of notice a pattern of your numbers. Seems like they're going down by 2. So -2 times 1 minus 1. So we get negative 2 minus 1 would be negative 3. Looky there, it's going down by 2's. Then I have y equals negative 2 times 2 minus 1. So I get negative 4 minus 1 would be negative 5. Going down by 2's. Alright, so there's my ordered pairs. So I can just graph these and see what the graph looks like. Okay, so we're going to plot the points, and we'll have to kind of switch back up and look at these. So negative 2, 3. So we go backwards 2, up 3. And then it went down by 2, so negative 1, 1. Then we go down by 2's again, so 0, negative 1. Then we go back up. 1, negative 3, 2, negative 5. And there you have it. You can see that it makes a line. So I'm going to draw a straight line through here. And you want to make sure that you can include arrows on both ends of your line to show that it goes on forever and ever. Okay, and you might have kind of already saw that, but we're going to see, is the graph a function? Well, how could we tell? There's two ways we could tell. We could look at our chart that we made and look at the ordered pairs to see if any of the x values repeat. Or we could do, the vertical line test. And we can draw vertical lines through our graph, and you can see that they only touch at one point. So, therefore, if you wanted to say that it is a function, that would be correct because it passes the vertical line test and none of the x values repeat. Okay, one more thing and then we're finished. Function notation. If you see f and then x in parentheses, you read that the function of x, or a lot of times they say f of x, and that just tells you what value to plug in for x to find the value of y, or the value of the function. So the x part in parentheses, that just means that we're plugging in numbers for x. So if you look at these, y equals 2x plus 4 and f of x equals 2x plus 4, those are interchangeable. Y and f of x are the same thing. So don't get too hung up on that. It's just a way to write it. It just tells me that I know this is a function. I don't have to check it. Okay, so we're going to evaluate f of x equals negative 3x minus 10 for f of 6. So that means that we're taking 6 and we're plugging that in for x. Okay, in this x and in this x. So, give myself a little bit of room to work down here. I want to find f of 6. And I take negative 3 times 6 minus 10. So I plugged in 6 for all the x's. So, negative 3 times 6 is negative 18 minus 10 equals negative 28. And so that is your answer. So f of 6 equals negative 28. Okay, that's all. So you can write a summary. I'm going to show you guys an example of one because I know you're still getting used to writing these summaries. But basically you want to have 1 to 2 sentences about what your notes covered. So what I would do is go back and highlight 3 to 5 main ideas, keywords that you can use, and then try to put those into a sentence. So this is what I came up with. If you need some help. Okay, I use the words relation and function because we talked about those. We also talked about the vertical line test. So my summary is you can tell if a relation is a function if none of the x values repeat. You can also use the vertical line test on a graph to see if the lines touch more than one point on the graph. So that would be an example of a good summary using 3 to 5 of the main ideas that we talked about in our notes. All right, thank you guys very much. Make sure you ask questions in class.